Yeah, first of all, thank you for so much for having me today. It's been a pleasure to actually come here and yeah, to be in London again after Flutter Live. So cool. So yeah, today I'm going to talk about motion or animation in Flutter, and basically more about the concepts and the how do you say it? The idea behind the framework and how the whole animation framework is basically built. But before we start with that, I just like to ask you, or get you the definition of animation. And animation is also known as the state of being full of life or vigor or liveliness. And the second description is the technique of photographing successive drawings or positions of puppets and models to create an illusion of movement when the film is shown as a sequence. Basically, Disney movies, and I think Disney was also the company that made that really, really popular. And they also found the 12, I think, animation principles. So it's also very interesting if someone is interested into that. So basically, what is an animation? I think everyone knows, GIFs from the internet. This would be an animation. So it looks like motion, but it's like basically just single frames. And then some of you may ask the question, why are we doing this? Because if I talk to people, especially developers, about that, they're always like, oh, yeah, I'm not the UI guy, but you know, this is Flutter, and I think Flutter is also a big part, or the biggest part is UI, and being a UI framework, multi-platform, not cross-platform. And right here, I have a sample. And if you just like look at this screen and try to get what I am doing in the next 14 seconds, I guess. So basically opening up an app and sharing a photo. And as you can see, I disabled all the animations in between. And this is like, yeah, basically shared to Twitter an image. And this is like 14 seconds. And this is actually not taking that much longer with animations attached. So what you saw is maybe if you compared it, you maybe lost track at some point. And this shows actually how important animations are in apps, although you maybe not think that they're that important. So this is the whole thing again, this time with the normal animations involved. And you can see that you really know something pops up from the bottom. You see a loading indicator. Now when you press share, it pushes everything up. It opens up the new app, and you have like this whole context of what you're actually doing in the app. So it helps people a lot. So a friend of mine once said, animations are a subtle art, and you can basically divide them into two categories. And then the first ones are the ones that guide the user, what we've seen in the example before, and that are needed for the app to actually work and to get the user, to help the user so it doesn't get lost in your app. And the second ones is those which make the app stand out and make it like a joy to use. And Brian and me, we had also a talk earlier today, and we were thinking about apps with or without nice animations, and probably those with the nice animations, they will be chosen by most of the users. So if you have two equal apps, probably the user will choose the ones with even like subtle animations, or maybe they don't even realize in the first place that it's like an animation, but at the end, they feel completely different if you put them side by side. So in Flutter, we have this class which is called abstract animation, and it holds a type T. So this could be basically everything, like every object, every kind of value. And additional to that, it holds the current status. So if the animation is playing, if it's playing forward or backward, if it's dismissed. And it implements the value listenable, so basically you can subscribe to it. And if the new animation changed the value, those callbacks are getting called. The animation controller itself is basically extends animation with the type double. And some of you who probably already used the animation controller know that it also has those four quite important methods which say like forward to basically play the animation, reverse to reverse it, we have repeat to basically repeat all over again, and to stop it. And the interesting part here is that we usually have a default lower bound of 0 and an upper bound of 1. So the animation controller is basically used, as the name already said, to control other animations, but we can also see how far we can get just with the animation controller itself. yeah, and I think I forgot one part, point. You can also like set the animation to a specific part. You can basically skip or yeah, is it see through through a video in this animation, or set the duration and stuff like that. So the code of an animation controller looks like this. I hope you can see this at the end. Actually, I refactored all my slides during Brian's talk because it was way smaller before. So this is why the bottom is cut off, but I hope it's okay. So as you can see, we're basically just having an animated counter which extends stateful widget. And as you can see, we have the animation controller. We basically have just a center widget, which then takes the controller value to a string and takes the substring, so it's not like getting huge. And yeah, and in its state, we just initialize this controller, and on dispose, we dispose it. So this is what we get from that, a beautiful, yeah, counting up and down value, because we called repeat with reverse set to true. And yeah, but the interesting fact would now be what have those kind of code snippets to do with the animation controller itself? Because we had like the abstract animation class, and we've seen that actually from itself it does not change anything. So we need to have some kind of callback, and this is actually where the single ticker provider state mixing comes in. This like uses the ticker provider to get callbacks from the framework when a new frame gets rendered. So we know basically how much time was elapsed when between calling the two frames, and those information is again feeded into our animation controller. And this is also this argument, which is called, I don't know, I can use this, which is called the vsync. And so it uses like this ticker provider. And yeah, you set the duration. And one more interesting thing actually you have to do here when using the animation controller is that you add this listener and call set state. So why do you have to call set state? Because as I said, the animation controller itself just implements the animation, but this doesn't change a thing right now. It's not connected to any UI yet, except for that we're just taking the text widget and putting in, basically reading out the controller value here. So in order to update our UI, we just call set state, or we add the listener to animation controller, which is also a value notifier because it extends animation. Yeah, and then on every change basically calls set state. So what can we do with this information? We can build some pretty basic animations right now. So if you have a look onto the left, we can use a container and then just an opacity widget, and then just fade it in and out. So basically, we use the same controller I already shown you, like with instead of just putting the value into a text widget, we use it here as an opacity. It goes from 0 to 1, right? And then from 1 to 0 again. Or we do the same thing here, but this time with a transform widget, and take the controller value, multiply it with pi, and yeah, that gives us this 180-degree rotation. So, but now you may ask, do we always have to call set state and stuff? And it's quite a lot of boilerplate code. There's actually help for that. There's the abstract animated widget. This is used with the listenable objects and calls set state internally, so you don't have to in your code. So actually, Flutter also comes with a lot of pre-manufactured animated widgets, which are called transitions in the beginning, so in the end. And so you have the align transition, a position transition, a rotation transition, a fade transition, a scale transition, size transition, slide transition, and many, many more. It's just like some of them which are there. And basically, those are animated widgets you can directly use in your code, which looks like this. If we're going for a fade transition, so we're not using the opacity animation anymore. So the cool thing is that we are actually missing the set state down here. So we can just use the animation controller and call the repeat, and we basically just pass it in here into the opacity. And yeah, basically this, it updates itself because on every change of the value of the controller, we update the widget. Yeah, so the whole thing looks then like this, exactly the same like what we had with opacity widget, but yeah, Flutter handles some code for us there. So the next thing is, if animated widget is not enough. You can still use animated builder. So if you want to handle your own state logic, you can use the animated builder widget, which looks like the following. Yeah. So basically, we would have a child, which is just like this, like a container, like which is 200 by 200, and still has our logo. And then in here, instead of using the opacity widget or the fade transition, I use the animated builder with, again, the animation as the controller. The child is basically, just this function or this container thing. I just put it into this function to make it look cleaner. And in here, we have the builder, which then also gets the child, and then basically does the animation part of it. And the cool thing here is if you're using this animated builder, you can also say, this child, if it's like a pretty complex widget, then it can help also improve the performance of the code. Yeah, and still down here, the usual stuff with the controller. Oh, yeah, I could have also used that earlier. But now, maybe some of you thought, okay, now we have this animation controller, which just outputs values from 0 to 1. What if we want to not only have values from 0 to 1, but maybe from 0 to 256? I know you can just basically multiply it, but it gets different if you think about maybe offsets or think about colors. And for that, we have the tween. And the tween is a linear interpolation across a predefined range. So basically what I said, if we want to have an animation from the color red to the color blue, we can use the color tween. If we want to have a tween in an integer range, we can use the int tween, or we can even have a size tween. And there are, as I said, also many more. As you can see, in Flutter, they have very often those namings that they have the word tween or transition, and then you can just basically look up into or search the documentation and probably find what you're looking for. If it's a normal kind of use case, it probably is already covered by one of the widgets that are shipped with the Flutter framework. So, okay, how does this look? So basically, this is our default architecture, I call it now. Instead of basically having the animation down here, which is a color tween, and we say begin, because we need a beginning, like the 0 for the animation controller, and an end. As for us, the end is the color red. So we want to have an animation from the color blue to the color red, and then we animate it to get an animation out of it with the controller as a parameter. And up here, we also have the build function, and we'll just return a container which has the background color as basically just the animation value, so the current color from our animation. And down here, we still have the set state to make it just as simple as the first example. And the result will look like this in Flutter. Yeah. So coming to the end of our first section, too long, didn't listen, I don't know. The first part is we have the animation controller, which basically drives the animation and is animation itself. Mind blown. And we had a glimpse at animated widgets, which make it easier to handle the set state code, and that you don't basically have to call set state in your current widget, and you could even make it or integrate it in a stateless widget. And then we introduced the tween to not only go from 0 to 1, but maybe from a color to another, or from a size to another, or whatever. So basically, our beautiful animations, what we could do with this code, is like this red dot just going up and down. But if you have a look at the second dot, the blue one, you see that it moves quite differently. It moves way more naturally. And because we live in a world that is controlled by physics, everything that follows those physics rules feels so natural to us. And this is also a thing why you should try to build your app as naturally feeling, if that doesn't sound weird, as possible. So, and guide the user with that through your app. Yeah, and this is called easing. Easing is basically using a curve to interpolate the values again that go from 0 to 1, and give it some kind of not linear, how do you say it? History, whatever, I don't know. Yeah, so as you can see, the easing there. And this is achieved by the curve, and those easing curves are used to adjust the range. This is the definition. It's probably way more accurate what I just said. The rate of change of an animation over time, allowing to speed up and slow down rather than moving at a constant time. And also here, we have the code for our red dot. So basically, let me see. Oh, no, I didn't want to have this. Let me go here again. Yeah, so basically, this is the code for a red dot here. You can see it's still more or less the same. We have our animation controller here. We have this time an animation of the type offset, so we don't have a double here. And down here, basically, we have the tween, which begins at offset 0 and goes to offset 0, 300. So it's basically just moving vertically. And you basically animate this. And the code, again, is the same. That we need the listener to update basically the views and stuff like that. And because Flutter is an awesome platform, they already ship with a lot of curves that come with the framework. And I know that looks a bit crazy, but yeah, and those are just like a few of them. There are even more curves available in the framework. But it's just like to give you some like short overview of what you can actually animate in there. So in order to basically come back to our little dot, we just do this. Instead of our animation, we add, instead of having our animation just as a tween and calling animate on it, we can simply chain it with a curve tween. And we say the curve should be the normal ease curve, and then we animate it, and we have this natural movement of the ball going up and down. Basically, the curve just a mathematical function. And you also have another approach of basically achieving the same. You could also call tween dot animate. And instead of using the curve tween, you can use the curved animation, which more or less does the same for you. Instead of taking just the curve and being chained with another tween, you use the controller as a parent, and then also set your curve there. Yeah, and the next question would be probably how to make like more or bigger animations than just a single animation. Because right now we're able to basically animate every widget or every item on the screen. And for this, we have the interval. And one of the most important things here to know is that the interval is also a special curve and also behaves like a curve, and can be used to delay the animation to orchestrate some animations with each other like this. So you have this sample here, and this is something that looks like more or less like a transition. And if you want to basically have this staggered animation of the first image coming up, then the text, and below the button, we have to orchestrate like a few animations together, but we can use only one animation controller for that. So this is actually how that looks. I hope this is not too much code in here. So here we have our animation controller, and we have 3 animations basically for the offset. And the offset changes at different time, so we need an animation for the image, the header image, for the text, and for the button. And since we're also doing an alpha animation, an opacity changing animation, we also define an animation of the type double, which goes again from 0 to 1. And is called animation header alpha, animation text alpha, animation button alpha. And down here, you can see the structure of the whole very simple screen. Everything is basically wrapped in a column. And then you have an opacity widget. And the opacity takes, the first widget takes animation header alpha, because this is our alpha widget here. And down below, we have our, the child, which is a translate widget. So we can actually make it move up. So we have both aspects, first the moving up, and then the animating of the alpha value. And the same applies for the other 2 widgets. And if you go down, you can see in its state, we have our animation controller again, the set state. And in here, it's going to be like a bit more interesting this time. We have our animation header up. We have a tween of the type offset. The beginning is the offset 0 and 100, because we want to make it come in like from the bottom, and at offset 0. We change the whole thing with a curve tween, with a an interval from 0 to 0.8, so that it will last to 80% of the time of our animation controller, because this is the first element. And as a curve, we want to have the curve ease in, out, cubic. And we animate this with the controller. And as you can see, for our animation tech step, we have also the same offset, because we also want to have it like to animate the same distance. And and here the only difference is basically the interval when it starts. It starts from 0.1 and goes up to 0.9, and the last one starts 0.2 and goes up to 1.0. So we just have like a 100 millisecond delay in there if our animation controller is 1 second. And down here we have the animation header alpha, the alpha animations, and here we can just use curved animations as discussed before and use our normal animation controller from 0 to 1 and have our interval in here, because we just want to have the alpha animation from 0 to 1. So we don't want a different tree in here. And that's basically it. So the too long didn't listen again. Curves are used to make animations look smooth, and intervals are just curves basically to delay in our animation. And with those you can orchestrate your bigger whatever animation you have planned for your whole screen. So the next question is, now you tell me, Frederik, it's really cool and I like it, but there's a lot of boilerplate code involved. So if I just want to write a simple animation, it sucks, no. And I was like, for that reason, there are implicit animations, like another type of animation. And those will automatically animate their value if you change them between two like set state calls. And this is like pretty handy if you have something simple that needs to be animated. And those widgets basically start with the word animated. So if you search again the Flutter doc, you can find everything like align, crossfade, animated container, animated padding, animated positioned, animated opacity, or animated switcher, and switcher, pretty good. And it's also as easy to use. So if I just show you the code for our animated, in this case it's an animated container, because basically it animates all the attributes a container has. So if you have a look at this very simple stateful widget, which is silly, but doesn't matter for this example, it's good, which just has like a Boolean value, and it checks if it was tapped, then has like a simple gesture detector to like swap the tapped state. And down here, there's the animated container, and all those implicit animated widgets, they take a duration and the curve. So basically, the same stuff that goes into our animation controller, since they're powered by an animation controller. And now down here, I just do like a check if the container was tapped, then I switch like basically the height and the width and even the color. And as you can see, this is the result of it. And everything gets smoothly animated. And the cool thing is that it even works, as you've seen, if it didn't even like finish correctly. So it saves the state and knows the current position of the animation and does everything for you. And this was already like the intro to like animations and the animation framework. And there are even more like interesting topics, and I wanted to cover even more. But I also didn't know if it's that good to have like that much code and in one session. So the interesting topics cover also like physics-based animation. Probably this could be also a talk for itself. Then page routes for custom transitions, what you've seen, the orchestrated animation sample could basically also be done with a custom transition or a page route builder and stuff like that. Also very interesting. And there's also Flare. Probably who still doesn't know Flare. Basically, it's the awesome SVG animation tool by 2 dimensions. That's it. So thanks. If you have any questions, let me know. I'll be glad to answer them. I don't know.
Right. Who's first? Who wants to ask the first question? Don't be shy. Come on. David.
What do you use for your slide deck?
What I'm using for my slide deck? It's a Flutter app. No, it's not. It could be actually a Flutter app, and I would love to have made it in a Flutter app, but it's just Keynote. So just like PowerPoint for Mac. I don't know.
Anybody else? Good. I will add that I'm going to be getting him back to talk to us about the rest of the stuff he was talking about just now.
So this question's maybe a little bit unfair, but I was working on a little project for the Flutter Create Challenge thing, doing an animation using a custom painter. I'm curious how badly I messed it up in terms of the approach I took. What would roughly be the correct or the best practice for, I guess, using an animation together with custom painter? Is it just use an animation builder and the custom painter, or?
That's actually a good idea, and I think it depends on how you're using the animation. If you're just using the animation to basically repaint, you're making weird faces, Brian. It's like, no. But I think if you're just using the animation to update your drawing path, or I probably would need more info on your project now, but you probably could use that to get a callback and do the re-rendering. But yeah.
Just
yes, the Flutter Whisperer. Come on, come to the front.
I was going to say custom painters, custom clippers. They both take a listenable as a parameter to reclip or repaint. So what's great about that is on scroll events, which are listenables, on scoped models, you can also rebuild or repaint. So the actual thing to do with animations is pass the controller or an animation into the custom painter itself, and it will automatically repaint itself every single time the value changes. So easy peasy.
Anybody else got any other questions other than just animation? Brian's ready and waiting, so is Simon. Or is it just time for the pub? Because it looks like it's pub time to me. All right, pub time. Thank you, Fred.
Thank you.
Thank you, Brian.